When we started talking about covalent bonding, we talked about how bonds could be polar or nonpolar. This was the example of a polar bond, the H to Cl bond, where the H was slightly positive because it had a lower electronegativity, and the Cl end is slightly negative because it had the higher electronegativity. And these were the little symbols we used to denote which end was the positive end of the bond and which end was the negative end of the bond. Well, HCl, in addition to being a bond, is also a molecule, hydrogen chloride or hydrochloric acid. So that tells me that this molecule would be polar. Now, if we have molecules with several atoms in them, they can also be polar or nonpolar, just as bonds can be polar or nonpolar. So, in this case, we're looking at two different molecules. We're looking at CO2 and we're looking at H2O. In CO2, we have polar bonds, and in H2O, we have polar bonds as well. But something very different happens in these two molecules. So we can see that the C to O bond is polar because of this little arrow notation. The positive end is over the carbon, the arrow end, the negative end is over the oxygen. But now, since we have two C to O bonds and they're oriented opposite of each other, what ends up happening is that the positive ends and negative ends tend to cancel out. So that if you look at the overall molecule, there isn't a positive end or a negative end. Both the bluer ends indicate that that's kind of negative, and the positive, more positive part is in the middle. So even though these are polar bonds, this whole molecule would be nonpolar. This is different than H2O. In H2O, we do have polar H to O bonds, and the H is the positive end and the O is the negative end. But because water is a bent molecule, what happens is that you do end up with a positive side and a negative side. Because both H's end up on one side and the oxygen ends up on the other side. In addition, you also have the pair of electrons, the two pairs of electrons up here. So this side of the molecule is negative, this side of the molecule is positive. So we would call this a polar molecule. And we say the molecule has a molecular dipole. That just means that there is a partial positive side and a partial negative side to the molecule. So we can use Lewis structures to predict whether or not molecules will be polar or nonpolar, even if they have polar or nonpolar bonds. So when we start to look at the molecule, we ask ourselves, what type of bonds are there? Are there polar bonds or are there nonpolar bonds? Well, if you have electronegativity values for the atoms, you can calculate the difference and figure out if the bonds are polar or not. But if you don't have electronegativity values, like you do not have on your chart of the molecules you drew Lewis structures for, the only time you're going to call a bond nonpolar if it's two of the same atoms bonded together. So like, for example, O2. Since they're both oxygens, that would definitely be a nonpolar bond. So the O2 molecule would be a nonpolar molecule. So if we don't have electronegativity values, we can start by assuming that the bonds in the molecule are polar. So once we come down this side, we look at what is the geometry. And you can see your choices are symmetrical or asymmetrical. And basically what that means is, if it's symmetrical, means that there are no lone pairs on the central atom. Asymmetrical means that there are lone pairs on the central atom. Because you remember from the geometry lesson, even when you have lone pairs, they push the bonded pairs of atoms out of the same plane sometimes. So, for example, in H2O, the four sets of electrons are arranged in a tetrahedron, but the shape is bent because of the lone pairs. So if you look at the geometry, if you look at the Lewis structure, and you see that there are lone pairs on the central atom, you can conclude that that molecule is polar. So again, The lone pairs must be on the central atom, not on one of the terminal atoms. We're just looking at the atom in the middle. So in the other case, we could have an atom that has a central atom that only has other atoms bonded to it, no lone pairs. We would call that symmetrical. So if it's symmetrical, we still have to check one other thing. Are all the terminal atoms the same? If all the terminal atoms are the same and there are no lone pairs, the molecule is nonpolar. If the terminal atoms are different, even though there are no lone pairs, if there are different elements, then we would call that molecule polar. So if we look at CH4, we don't know if the bonds are polar or not because I'm not giving you electronegativity values. So we can assume to begin that the bonds are polar. It's a symmetrical molecule. So, and all the terminal atoms are the same. So CH4 would be nonpolar, as opposed to NH3. NH3, we can assume that the bonds are polar because we don't have electronegativity values. There are lone pairs, which means that that molecule is going to be polar. So you can use this little decision tree to figure out whether a molecule will be polar or nonpolar.